All right, hello, welcome back. I am going to be moving on to the next step here. This is the PCB milling series. So in the first video, I went through how to take your designs from Easy EDA, and I gave some design considerations there. But from there, how to take your designs through FlatCam and spit out the CNC jobs and the G code that you need to send to the CNC machine in order to actually physically make the board. So in a follow-up video, which I titled, part 1.5, I corrected some of the mistakes I made in the first video. This video will be a continuation of that, where I will take the designs and the G code files that I exported and show what it looks like to actually mill those on the CNC. So I've got a separate camera that I'm going to try to record some time-lapse videos, and I guess they'll just be in this video. And then I guess I'll try to narrate over them as best I can. But essentially, what I'm going to be doing is step one is to load the files and create a height map. Which I can do now. So the best way to go about making a height map, and so I've taken the liberty of already loading up the PCB blank on the CNC machine, but the easiest way to do a height map, and so I guess I should talk about height maps. So we have all these instructions that are 3 dimensions worth of, move the head of the thing here and spin it here and spin it this fast, and all the different parameters. But in the real world, that would work great if you had full control over the physical constraints in the real world. But what happens is these little blanks aren't perfectly flat. If you actually hold them up to the light, you can see they have a little bend to them. And then compound that with the fact that you're putting it on a physical surface. You're clamping it down on the sides, and you'll see that on the CNC machine. And so depending on how much force you clamp down with on either corner, you're going to change the surface of this, of the actual board, by fractions of a millimeter, really. But that matters, and it matters a lot because this is only 1.7 millimeters thick. I don't have my calipers. But the more important thing is that we only want to send the tool past this copper as little as possible, really. So what I have found is that it's like 0.11 millimeters. Seems to go deep enough into the copper and account for any of the mistakes, even in the height map, enough such that even if the board is warped a little bit past the height map, it still kind of it evens out. But the importance of the height map is because these are, you affect the layout, the overall. There's peaks and valleys in it. You affect it with the holding mechanism, and then the boards themselves aren't flat. And then whatever surface you're milling on, I happen to have a 1/4-inch piece of plywood. I did not mill that flat, so one technique you can do is actually, before you put a board or anything on your surface, is if it's wood, you can clamp it down first and then mill a completely flat surface so that it's flat in comparison to the movement of your CNC machine. But you don't really need to do any of that if you have a height map. And what a height map does is you can send the CNC machine down, all the way across the size of your design. So in this case, it's 28 millimeter by 28 millimeter. So it starts at 0, 0, goes 1, 2, 3, 4 until it's out to 28 millimeter. It goes up a row and does the same thing back, and then 4 by 4. It does a whole 4 by 4 grid across the size of your instructions. And so when I load this outline layer, the cutout instructions, this is the actual board. This is the 28 by 28 millimeter layer or outline. And so what that allows me to do is, here's the height map area, and you have to get a beta version of Candle to have this height map functionality. Unfortunately, I wanted to run a lot of these tools on my Raspberry Pi, but I think the beta version of Candle, or the new version of Candle, doesn't work in ARM64, or there's no binary for it. And so I'm doing this on my laptop now. Anyway, so to create a height map, you click the create button here, and now you're in height map edit mode. And so over at the CNC, I've got a probe set up, and I suppose I'll put the video here now, but you'll see it in a second. But I've got a probe set up so that I can do this whole height map. So all I really need to do, I've already gone over there and set everything up. So all I really have to do is hit probe, but I need to turn the video on. So if I hit probe here, I'm just gonna... So as you can see on the screen here, the I don't know, my mouse is all the way in the other room. There we go. You can see the head of the CNC, the spindle moving around and doing its thing in this kind of 3D construct here. But the and I guess side by side I'll put the video. It's a time lapse though. Anyway, this is creating the height map, and then I guess I'll talk more about it when it's done. Okay, the height map is finished. So now what you can see here is the height map expressed as a 64 by 64 array. It's a big grid of interpolated coordinates. So what it did was the probe went to each one of those blue dots and took a reading of what the Z height was, and then you can get an average across the entire grid, and it does that. It interpolates across the whole grid, and it gives this like river-looking effect. But you can kind of see where the low areas are. This is probably I clamped down the board a little bit more here, and this is farther away, or I clamped it down a little bit less here. And this is kind of what I was talking about. I've affected the surface area of this. I've affected the surface of this so that there's a little bit of a hill in the middle, or actually it looks like it goes up and up and up from the bottom left corner to the right, with a little river in the middle. But so I've got all these points now down here expressed up here, so I need to save this file so that I can apply it. So I'm going to save over. I have one already from the last time I messed everything up. But okay, now I've got the height map, and I've got a big enough height map that will cover the entire surface of the project. But I don't actually want to cut the outline or the border yet, so I'm going to, oops, I need to exit edit mode. So I want to open the drills, because that's one of the alignment drills. So in order to use this height map, since I switched files here, I need to actually reopen the height map. And then when I click this, you'll see it went by really fast, but that essentially set up, it changed all the coordinates. So for each one of these corners, I had XYZ coordinates associated with them, so it was supposed to go a certain amount into the board when it drills these holes. But based on the height map, if this corner is a little bit lower, which it is, it'll drill a little bit deeper because the coordinates were all just changed as I click that button. So what I need to go do now is go switch the drill bit and get to drilling these. And I'm just going to do these drills and real quick just do the alignment drills, and I'll do the regular drills too so that we can move fast on these. But I'm going to pause the video. And okay, so doing a little voiceover here. I just didn't like the audio from the other camera, so I'm just going to talk through some of this stuff that's going on the screen right now. But I'm getting ready to mill the top of the board. I've already created the height map, and Right now you can see me opening up the top layer. And so right here I'm opening the height map and applying it, and you can see kind of that took a little bit longer than the other time. It was applying the height map across the entire all the instructions, and it just there's a lot more instructions there, so it takes a little bit longer. And here I've got a because I'm milling now. A moment ago I was drilling, so now I've got to switch out the bit, of course. So I'm putting the 1/2 millimeter drill bit, or sorry, the 1/2 millimeter end mill bit on, and back to the candle program, doing a little bit more setup here. I know I've got to attach the probe, got to go back to the origin, make sure that the new bit is set up correctly. So you want to make sure that you probe to make sure that it's at 0, so that the bit, as you put it in, you just need to calibrate it essentially. And probing is the way you do that. You hit that probe button at the bottom left, and it searches for the board, or searches for a, it goes down until the probe completes the circuit. And that basically sets, instead of eyeballing it, it allows you to set the height of the bit properly, so it senses it from the origin. And every time I do it from the origin. See me clicking the button right there. And now I'm going to hit send. So in a moment I'll switch to the footage that I took of milling the top layer, but I wanted to kind of show a little bit of the animations here too. So as you do any as you execute a CNC job in Candle, it not only tells the CNC what to do, as you see here, but it also shows you in the screen as well. So it shows you kind of a 3D representation of that spindle and where it is in relationship to all the holes and everything. It's neat. And you can just see that was a quick editing trick. It's already done, but now you get to watch this. But I'm gonna skip ahead, and we'll get right to flipping the board next. Okay, so here you'll see me. I'm just kind of visually inspecting the board. I'm gonna blow it with some compressed air in a second, but I'm just looking at the traces. Not that they're not traces yet, I guess they're just pads, but there's some tiny traces on the top. But I'm just looking, visually inspecting, making sure everything's isolated. Pointing out some things, I guess. Again, this audio wasn't that great, so I'm just doing some voiceover here. So now I've decided it's time to flip the board, right? So this is always kind of a nerve-wracking experience. It's like you've got this thing locked down, and then you've got to undo it and sort of trust that your alignment holes are good. I flip it over on the y-axis and put it back. Then you'll see me align it. I've got this little ruler I got from I think it's Adafruit, a little PCB on its own, kind of some surface mount solder or pads on it, I should say. But it's a pretty neat ruler. I use it to measure some things, but I also figured out that I can use it to align or kind of square up the edge of the board so that it's a lot easier, and it really, really makes it quick to align. I've never ever aligned anything that quickly. I pretty much get it right after finding the hole and setting the origin. I pretty much get it within 1 or 2 tries of moving it around. It's just, I'm going to do it this way from now on. I actually also cut that piece of plywood down to the size of these big boards that I have. So I was having some trouble before where I was trying to mount the copper. I was trying to mount the blank, and I just couldn't fit those little latches across it. Not really sure what I'm saying there, but probably talking about how I lined it up. But yeah, I mean, I don't think I need to show the whole thing here, but this is just the flipping process. I guess I'll Oh, I guess the alignment's coming up, so I'll skip ahead to that. So here you can see I've switched out the drill bit. I've got the 1mm drill bit back in there because I like to use the 1mm. The same bit I used to drill the holes is the one that I like to use to align the board. And I've already found the hole at this point. I've set the origin and I'm off at the corner trying to test my alignment and see if everything lines up. To give it a second here. So I'm going to the next corner and then you'll see, I mean, I'll speed this up, but there's, I go to every corner over and over and over again usually, but I think it's pretty quick with this one, so I'm going to speed things along here. Eventually I feel that I have everything lined up, and that's when I will move on to milling the bottom part of the board and doing the cutout section, but we'll skip ahead. Okay, so actually here I wanted to stop and just kind of explain what's going on. I am now reprobing, creating a new height map. So that's a really important step. And actually, this is kind of where things go a little bit wrong, but I end up fixing things most of the way through the video. I figure out that I've got a problem with the way things are mounted. But right now I'm setting up a new drill bit upside down because I've realized that I need to, I know I need to probe the bottom of the board so that I get a new height map. But the reason I'm doing with an upside down drill bit is because I've got a bunch of 1mm holes all over the place. And if I switch to the 1mm drill bit, it's slim, but there's a potential that I find one of the holes. But if I switch to the 0.5mm drill bit and use that as the probe, first of all, it marks up the board because it's so small that leaves little dots all over the place. I don't like that. But if there's a much larger, it's half the size in diameter, of the drill bit that I use to drill the holes. So there's a larger possibility that I hit one of those holes. And what would happen when I'm probing if I hit one of the holes is that the bit would just continue to drive down through into the wood and snap off, but it would be inside one of the holes. So that may be a bigger problem. But I don't want to snap any more drill bits. I did that in the last video, and I've done that. I've wasted so much money on drill bits at this point, just being careless. So I tend to, when I probe things, I tend to be really careful now. But the problem that I run into here, you can see off to the right, or up in the middle of the video somewhere, where the black alligator clip is attached to the mounting bracket. You can see the mounting bracket is kind of cockeyed a little bit. That's going to come back to bite me because the height map is being generated now. Everything looks good, but then by the time I actually get over to that corner to mill with the 0.5mm drill bit or mill bit, it must have shifted so it doesn't quite cut into the copper like it should. So I end up redoing the entire height map again while this thing is locked down, and then it's still a problem. So I end up actually putting a shim in there while the thing is running. It's funny. I'll try to work it in here, but you'll see me bang in a 30-degree V-bit underneath this board just to raise up that corner as much as possible in the moment. I'm going to skip ahead to that or something else, but yeah. Here you'll see me switching the drill bit back out. I've done the probing. I think everything's good. Kind of ignorant to the fact that there's a looming problem coming up, but that's okay. Most of the board actually gets milled pretty successfully in this run. It's only when I get to the bottom right corner that things start to go awry, and I notice pretty quickly, so I'm able to adjust things as the job is going. But here I'm just kind of probing and getting started. And this is the moment where I'm actually making another mistake. I completely forgot. I loaded the right here. I loaded the top layer again. I flipped the board over, I aligned everything, and I go to start milling, and I realize that I loaded the top layer. Oh no. The top layer is completely incompatible with the bottom layer, so I've actually ruined the bottom layer at this point. But only in 3 places. I've ruined some tracks or traces and cut through them, and I just really have to solder over top of that hole. And it's really thin because I managed to stop the job before I went over those spots several times. I only went over them once, maybe twice in a couple scenarios, but in a couple of them. But yeah, ended up not being so bad. But now I do have a bit of a problem, which I'll explain at the end of the video with the board. Some of the components are going to be hard to solder on, but we'll get there. And so things are moving along here. I'm milling the bottom of the board. I've corrected my mistake. I just put the right layer into candle, and now I'm milling the bottom again. So those mistakes were already made. I've already got the holes in the traces, but I know I can fix them later. And I want to show this because I think right around now you can see I notice something's going wrong. Something's wrong here, or maybe it's here because now it's finally starting to get to that corner. But I was watching this like a hawk, and I usually don't, so I'm glad that I did, although it wouldn't have been that big of a deal to let it finish. Okay, so actually I didn't realize this is where I noticed things were going wrong. I actually did let the job finish. I didn't notice until the end. I think I did notice, but I just let it finish because I was thinking about what to do by the time I realized. But so the next step is to, I've realized the problem, and now I've got to, essentially I have to remill this whole thing, but not everything, just the bottom layer. But before I do that, I have to redo the height map, because that's the whole point. Like, there was a big problem with the bottom right corner not being raised up as much as the height map said it was. It was lower than I thought, so it didn't cut that bottom right traces. It didn't isolate them, is what I should say. So I've got to redo the height map, and then not only have to redo the height map, but I have to redo the whole job. But then I do all of that, and you'll see that it still isn't quite cutting. I don't know if you'll be able to see that, but you'll see my reaction, which is to, like I said before, jam a. I tried a bunch of different things, but eventually, figured that the 30. Look, I see what the problem is here. Actually ended up not being the problem anyway, so I think I should have clamped down the top right corner too, and that would have evened things out a little bit. But what I'm doing now is just redoing the height map, like I said, because I've realized that it's not good, and now I've changed something about the mounting, so I have to redo the height map anyway, because even if it was good, I just changed it. So I'm just putting a drill bit in upside down here so that I can get through it. But then this is a problem because I've actually isolated some traces. So you'll see at some point, I'll probably make this go a little faster, but at some point it becomes clear that I'm about to hit a trace that's isolated. And so the way the probe works is that black alligator clip is attached to the screw over there, and that whole mounting bracket touches the copper on the board. So that's one connection, and then the other side is attached to the top of the spindle, which is touching the drill bit. So the drill bit, when it touches the copper, as long as it's not isolated, it touches the copper that's also touching that black alligator clip. It closes the circuit and everything works fine. But you'll see I'm doing the height map here, I'm probing, and at some point, here's the last one on this row. It goes up one, and then I think over one or two, and you'll see me reach over and hit the emergency shutoff switch on the CNC because I don't want this thing driving this drill bit into the board, or like over and over again. Here it is. I see, oh no, it's about to hit that trace, and it does hit the trace, so I'm like, oh, and then I hit the button. I'm like, I can't damage my CNC machine like that. It's a real big pain because I press the button, I turn it back on. Usually that emergency button makes it so I have to reset the entire CNC, but then it didn't do that to me this time. So I was able to resume, go back to the origin, put in my non-conductive probe, which is just a broken drill bit with a momentary switch glued to it, so that I can create height maps on things that are either non-conductive or, in this case, isolated, which had never happened to me before. So I never had to redo the bottom of the board like this. But here I've realized that, and now I'm putting on the other probe that I made. Fast forward a little bit. All right, so it's going at 5 times speed. You'll see me do the height map here, and you'll see me attach this other drill bit. It's not even a bit; it's just a probe. And like I said, it's just a bit with a momentary switch attached to it. It's a little tactile switch, and normally you would mount to a circuit board, but here it's just acting as a way to close the circuit on something that's isolated or non-conductive. So it's a handy little tool. I used it to engrave a screwdriver just to test it out. I wrote the word screwdriver on the screwdriver. The screwdriver was plastic, so but that's it. Now you can see at this point I'm already cutting out the board. Again, I made the same mistake. I mean, it's not really a mistake. It works well. It works okay. So I guess I figured out that I can do it this way. But I'm being very aggressive with the cut here. I didn't intend to do the full 1.7 millimeter or whatever the job is set up to do. It plunges immediately down all the way and then starts moving laterally. So in Candle, I actually have the feed rate slowed way down to like 30%, just to make sure I don't snap this bit, because I like this one. I don't want to buy any more bits. So, but here I'm cutting out the whole board, and then you'll see me actually take this off and cut it out. And here you'll see my method for popping these boards out of the blanks. I just use a standard chisel, like a woodworker's chisel, and a little hammer, big hammer. But yeah, this thing just pops right out. It's pretty loud in the video. I didn't want to share, you don't want to pop anybody's eardrums, but this works really well. I tried cutting things out. Look at that last one, just pops right out. And then I'm headed over to get some sandpaper and sand those little nubs off. That might show you with the camera for a second. It's funny because I'm actually narrating this as I go, but the microphone was just so terrible in that little camera that I'm using. It's a knockoff GoPro, so I need to get a separate external microphone for it, and then I can just record there. But we'll do these voiceovers for now. So I'm almost done sanding, and then I believe that I take this over and do a little bit of assembly, just showing, not quite. Oh, no. Okay, so I'm going to bang in the vias now. I'm talking a little bit about what I'm about to do, I think. Yep. So I'm getting these vias, and or I guess I should call them eyelets. They're not vias until you put them in the board. But these are the wrong size for my setter. I have a little metal setter you'll see me use in a minute. But here I am putting one of those little eyelets in. I like to put them on the top of the board because they're pretty on that side, and then the bottom side is actually what gets pounded with the setter. So that's the side that's ugly. Here we go, pounding one. So sort of the trick with these is not to go too hard, because as you can see from that hole, they expand a lot. Banging them with a 1mm grommet setter that I got, and it's for leather working, really. I have the 1mm grommets that it came with, but the outside diameter of them is 2mm. No, it's 2.5mm actually, so it overlaps the trace next to it, even with at 2mm. But they look so good when I use them. But here I am testing some traces, and kind of explaining what the whole point is. I just put an eyelet in. It's now a via, and it actually, I got lucky on that one. I pounded that in, and it automatically, instantly connected both sides of the board. Sometimes with the vias, when I bang them in like that, it doesn't quite touch the bottom of the board, so I have to add solder. But I add solder to every single one of them anyway, usually, because it just keeps them in there and more secure, and just a better connection. Because if some of them aren't connecting to the bottom layer, then it's probably not a great connection to begin with. So I just put as much solder as I can get in there without going overboard, and make sure to overlap some onto the trace itself. Just kind of flood the area. But right here is still, I'm still just putting in all the eyelets, so this takes a little bit. And so here I'm just showing the little setter tool. I just don't use it for these. They're not meant for it. I got the tool with the 1mm grommets, and they're just not meant for it. So here I'm just testing and talking about what I just talked about here, which is the fact that sometimes these vias don't quite make connections. So I had to add solder. Okay, so what have we done? What have we done? What have you done? We didn't do anything. I did it all, but no, I'm just kidding. I don't know what I did because I don't have the board with me. Do I? Is this the one? Is this the one we just made? Yeah. So finished the board. Yay! It made some mistakes, right? So the major mistake that I made. Let me make this a lot bigger, since we're really not talking about designs anymore. You don't need to see my big ugly face. Anyway, so the major mistake was when I flipped the board, I reloaded the top layer again for some reason. I just had a brain fart and started to mill it. So what the top layer was, if you remember, I can just flip it over and show you, but these are all pads, individual. So if I flip it over just like that, it started to mill these pads out, and then it would have gotten there, and I forget the exact sequence, but it did get up here actually, because it cut through these traces too. So I had to add a big hunk and glob of solder between the track there, which I normally don't have to do. Like you see over here, this is all I normally have to do, which is putting just a little bit of solder down in the... This is just a better camera, I don't understand. Better lighting. Just a little bit of solder, but then I had to do it that way. Kind of just these big globs, and I don't like that. I don't like it, but it works. I salvaged the whole board, otherwise it would have just thrown it out. So we tested all the traces, everything works. So the next step would be to assemble everything, which just gonna quickly. I went ahead and got out a couple header pins. just to show you what this thing looks like. I mean, I've got examples all over the place. This is the same board that I was showing off at the beginning of the video, but the beginning of the series. Oh, see now this. Oh no, it fits. Barely. I might have to remelt some of that solder. This might actually not work out as well as I thought. Or I can melt some of the plastic, I suppose, too. But yeah, this is going to be a challenging one to assemble because the mistakes that I made. But if I can get that solder a little flatter, like here, I don't think I'll have a problem. But like, in order to solder this, you usually put it in a breadboard is what I do. And like, you can just see, it doesn't want to go in properly because it's not. Oh, did I skew that? Yeah, I did. There we go. Anyway, I'm not going to fuss with that too much because I think it's problematic because of the weird solder joint there. And I say I'm not going to fuss with that, but then I get it working. Yeah, so you can see the gap there. That's what I wanted to show. There's a gap. It's not terrible, but it's there. That last pin actually I can't even get to solder. So that's going to be a little challenging. But those are things you can overcome. And if not, I'll just make another board and not make that same mistake ever again. And that's that. But I will be making the next video in the series within the next couple of days. I don't think it's the most important one. I think this one was, and because everybody can solder. There's plenty of videos out there for soldering, but just to see it through, I should do a complete board. Now the problem is I've already got the vias on here, and I actually don't even have a great method. Like I explained in the first video, I don't have a great method for UV masking. So I'm thinking I'm going to change this series to maybe 3 videos, and then maybe I can do a separate series on UV masking techniques. Do a short video on each, because there's attempting to do this before you assemble with like transparency masks and a UV light that I tried, and I have not tried to dilute the UV mask ink yet, and that was one of the more promising looking tips that I saw. But yeah, so we've gotten past the assembly, or we've gotten past the manufacturing step. All right, well, thanks for watching, and I'll see you next time.